Hello everyone and welcome back to Techmine Guru. I'm your coach Supratim and today we are going to tackle a massive shift in how you write code. Have you ever felt like your programs are getting less structured, hard to read, hard to test and difficult to maintain? If so, it is time to stop writing messy code and start building blueprints. Welcome to DSA lecture 29 where we will dive deep into classes, objects and linked list. Today we are taking you from basic programming paradigms all the way to dynamic memory and teaching you exactly how to master them. So let's open up the engineering toolkit for today's session. We have 4 main milestones on our map. First, we will explore the OOPS blueprint, breaking down classes and objects. Second, we will navigate the memory matrix to understand the difference between stack and heap memory. Third, we will uncover the interview trap and learn how to avoid it by understanding the difference between shallow versus deep copy. And finally, we will be breaking the grid by introducing the linked list today. And why do you think this paradigm shift was needed? Because earlier, whenever you used to write code, without using object-oriented programming, your code was less structured, it was hard to read, it was hard to test, and it was difficult to maintain as well. So let's kick things off with object-oriented programming or OOPS. So what is an object-oriented programming? Object-oriented programming contains class and its object. So think of a class simply as the blueprint of an idea which takes no space in memory because it is just a blueprint, so it will not take any space in the memory. And on the other hand, an object is a real instance of the class. An object shares the same properties and abilities that are defined in your blueprint, much like a car blueprint, which defines wheels, color property, body, engine of the car, and drive method. And when real car is made, that will be like a object created. So how does this look when mapping code to memory? So we divide our working memory into 2 main areas, which we have already learned in our previous classes. One is the stack memory, another is the heap memory. So imagine we create a class called class book. Inside this class, we define string, title, its author, and a read method. So how will you create an object out of this blueprint? So for that, you will use the keyword new. This is specifically for Java. So when we execute book b1 is equal to new book, the user defined data type and the variable name live directly inside the stack. So this b1 is an object. It will reside in the stack with a memory address. And where will your actual value will be stored? It will be stored inside the heap memory. So heap memory, this address will be there. And inside that address, suppose you have assigned the title of the book as Almanac and the author as the navel. So this is how you create an absolute object that is b1 from this blueprint class book. So to understand this better, this entire process is powered by the constructor. So earlier in the example of book b1 is equal to new book, we initialize the default constructor. So if you use a default constructor, it simply assigns default values, like making a string name as null and int age as 0. So we can also do this via parameterized constructor. For example, if we write student S1 is equal to new student, student name, student age, and student marks. So when you define the parameterized constructor in Java, you have to take all the parameters in your function input, and your function name should be exactly equal to the class name. And the default constructor as well as the parameterized constructor will not have any return type before the function. Similarly, in Python, you will write def for defining it as a function, and this init method, which will take 3 parameters, name, age, and PSP. So in Java, we manage this using this keyword, writing statement like this.name, this.age equal to age, and this.PSP equal to PSP. Similarly, in case of Python, you will use the self keyword, like self.name equal to name, self.age equal to age, and self.PSP equal to PSP. So this and self refers to the specific object currently being created in the heap. Now, I need you to pay close attention because we are entering the interview trap. Let's talk about copying object. How will you copy one object into another? As you remember that in case of data types, we used to do int x equal to y, right? That means everything which is present in the y will be assigned to x. But in case of object, this is not similar. So if you do student S2 is equal to S1, it will be like creating a shallow copy. So when you define ST2 is equal to ST1, a new object is not created. That's why it is shallow copy. Instead, both ST1 and ST2 will reside in the stack and will point to the exact same memory address in which actual value will be stored. So anytime you change anything in the ST1 object, so your ST2 object will also reflect the same changes. So if we run st2.name equal to Bob, then st1.name also becomes Bob. So how to fix this? So for fixing this, we will be executing the deep copy. So the goal is to isolate your memory in the heap, meaning st1 points to the address 20k, while st2 points to the complete separate address, like something like 3k or something like that. So if you use a deep copy, your st1 will point in a different address and all the values will be copied to the st1 and st2 will be residing in completely different address space. Suppose it is in 3k, but again it will have same value. So you can achieve this via 3 methods. One, by doing manual assignment. So while creating the st2 object, you will do new student and you will assign the new values to that student. Or you can also do it by extracting the properties of st1 object because it is already having those values. Since this is started with new variable, it will create a new object and it will copy the value from st1. So st1.name will go in student's name, st1.age will go in student's age, and st1.php will go in student's php. And the third way, which is also the cleanest way, is a copy constructor. So in case of copy constructor, we will pass a same class object as a parameter to the constructor. So now you don't have to manually one by one send the value by fetching the value from the different object, or don't have to hard code it in the new student object creation, but instead of that, you will pass the complete student object inside the same. And inside the constructor, you will write this.name is equal to s.name, this.age is equal to s.age, and this.php is equal to s.php. So now let's shift gears and look at the evolution of storing collection. For a long time, we have been relied on arrays and dynamic arrays, right? While they are still useful, they require contiguous memory location, making them rigid and flexible. So this brings us to the linked list. A linked list is a linear data structure that utilizes free memory in the best possible way inside the heap. So how will you define a linked list? So a linked list is represented simply by creating a class node containing the data and the next pointer, which is again of same class type. So it is like referring to similar object which the class is of. So under the hood, the class has an integer data variable and a node next variable. And also you can define your constructor as a node int x, where you can pass the value of the x to the member variable of the class node in the data. And you can assign next as null. So every time you create new node, your data will be assigned and its next pointer will be pointed to null. So now let's see how you will wire up the nodes. First, you will declare node head is equal to new node of 5. Suppose you want to create a linked list of 5, 3, and 8. So you will define node head is equal to new node 5. Now a head pointer will be created and it will store 5 in the data, and in the next pointer it will store null. Next, you will do head.next is equal to new node, because earlier this node was null and you want to chain it with 3. So you will create a new node using new node 3, which will keep 3 as data and null as the next pointer. But we have to insert this node inside the next variable of the head node, right? So that is why we will do head.next is equal to new node. So previously it was null and now it will point to this node. Similarly, for inserting the next element, you will simply do head.next.next. Head.next will represent this element and head.next.next will represent this element. And here you will do new node of 8, which will simply create a new object of this class where it will keep 8 as the data and null for its next variable. And to chain it, we will simply keep this complete object inside the head.next.next pointer, which is this one basically. So before wrapping up today's class, let's see a easy problem on linked list. So the goal is to access the kth element of a linked list where k is greater than equal to 0. So in case of array, time complexity for getting the kth element was very easy, right? It was O of 1 because you can directly access that element. But in linked list, not via O1 lookup. So how do we reach k equal to 3 when only we have a pointer to head? So let's see the code for the same. So we have defined a method get whose return type is node only. So we will take the head pointer as a parameter and the kth element which needs to be searched. Now we will make a temp variable of node type and we will do a shallow copy of the head to the temp variable so that head remains intact while we traverse. And going forward, every time when we have to traverse or do any specific task related to linked list, we will assign initially our head pointer to the temp variable, and whatever we want to manipulate on the linked list, we will do via this temp variable only. So now we will run a loop for I is equal to 0 to k minus 1 because we want kth element, right? Now inside that we will check if our temp is null or not. So this is like handling a edge case. Why? What if k was 5? So if you see, there are 4 elements only and k is 5. So we will not get the 5th element in a linked list of 4 elements, right? So for that, at that time, this node's next will point to null, right? So to handle that edge case, we will do if temp is equal to null, we will return null, saying that we have not got the pointer. Or else, every time simply to traverse the linked list, we will do temp is equal to temp.next. So initially head was here, right? So using this line, your temp will be here only. Now suppose k is equal to 2 is given for our question. So it will start from I is equal to 0. At I is equal to 0, head and temp are pointing the same variable 5. It will check whether temp is null or not. So 5 is not equal to null. It will not execute this condition. It will simply go to the next line, which is temp is equal to temp.next. It will now see the next pointed by the temp. So what is the temp's next? It is 3, right? So temp will start pointing to this one because whatever was there in head, so that head's next will be the new temp. new temp will be moving its pointer from this 5 to this 3. Similarly, in the next iteration, when I is equal to 1, it will check whether this temp object is null or not. It will check 3 is null or not. It will say no. Again, it will do temp dot next. So what's there in the temp dot next? It is 8. So now temp will point to this variable and it will break the link of this one. So since k was 2, so this loop will run till 1. So what is the final value present in the temp? It will be 8 only, right? So we will return temp from the function. And since the return type is node, it will be able to return the kth node. So if you observe the time complexity, so the time complexity will be O of min of k comma n, because if k is lesser than n, then in that case, we will get the result as O of k. And if k is equal to n, in that case, we will get the time complexity as O of n. And if k is greater than n, then also the time complexity will be O of n, because in that case, we will iterate till the last element, but in this case, we will not get any kth element. So it will be like running a loop from I is equal to 0 to n. So your final time complexity will be O of min of k comma n. And what will be the space complexity? Since you have not taken any extra space, like any extra array or map, so your space complexity will be O of 1. So let's summarize the engineering toolkit from today. The OOP blueprints. Remember that classes define the structure and objects bring them to life inside the heap memory. Also, today you learned about the memory management. That is, the stack holds the pointers and the heap holds the actual data of that object. And also you learned that how to protect your variables from getting shallow copies by introducing new keyword and copy constructor and making it a deep copy. And lastly, you learned how to break the rigid array grid and use linked list for scattered memory with O of k sequential access. So you just crushed lecture 29 today. You have successfully mapped memory boundaries, avoided the shallow copy trap, and logically linked your very first chain, right? If you found this lesson valuable, please hit that like button and subscribe to Techmine Guru. In the next lecture, we will be getting our hands dirty with problems on linked list. Till we meet again, keep learning, keep coding, and keep optimizing.